Hi students, in this video we are going to solve these problems. We will look at the first question now. Integration of cos cube x into sin x dx. If you look at this function, x is given as an input for cos, then the cos function produces the output. That output is raised to the power 3, meaning the output of cos x is given to the cubic function. Hence this is the composition function, and here we have another function. When we have composition function, we normally take first function as t. Here the first function is cos x. So we need to check whether when we do the derivative of first function we are getting this next function. Here cos x derivative is minus sin x, so we are getting it approximately. So we can start the first problem with the assumption that let cos x is equal to t. Then doing derivative on both sides with respect to x, we get minus sin x into dx is equal to dt. We need here plus sin x, so we just multiply both sides of the equation by minus 1, so we get sin x dx is equal to minus dt. So now the question can be rewritten as, in place of cos cube x we can substitute t cube, and then in place of sin x dx we can substitute minus dt. Then integration of t cube, we know that it is t power 4 divided by 4, this minus sign as it is. So this can be rewritten as minus 1 divided by 4 into, in place of t we can substitute cos x, then this power 4 as it is, and then plus c. I hope you understand this first problem. Now we will consider the second problem. In the second problem we have integration of square root of sin x into cos x. Here in this function x is given as an input for sin function. After that the sin x produces output. That output is going as an input for this square root function. Hence this is the composition function. In the composition function the first function is sin x. So we will check whether derivative of sin x gives this remaining one. We know that derivative of sin x is cos x. Hence we can start this problem with the assumption that sin x is equal to t. So when we do derivative on both sides with respect to x, we get cos x which is equal to dt by dx. Dx has been transferred to opposite side, so we get cos x dx is equal to dt. Now we can do the substitution. In place of sin x we are substituting t. Instead of square root we are substituting t to the power of half, and in place of cos x dx we are substituting dt. So integration of t power half is t power 3 by 2 divided by 3 by 2 plus c. Now we are rewriting this as 2 by 3 into, in place of t we are substituting sin x, then power 3 by 2 as it is, plus c. I hope you understand this second problem. Now we will move on to the third question. If you look at this question, here we have cosecant square x divided by 1 plus cot x. Here also we have this, actually this question can be written as cosecant square x into 1 divided by 1 plus cot x. This here x is given as an input for cosecant function, and then cosecant function output is given as input for the square function. Hence cosecant square x function is a composition function. Again 1 divided by 1 plus cot x is also a composition function. So what we can do is we can check whether when we do the derivative of cosecant square x we are getting this cot x or not. Similarly we can check whether 1 plus cot x, derivative of 1 plus cot x gives cosecant square x. When we check it, definitely we can say that 1 plus cot x will give us the derivative of 1 plus cot x gives us cosecant square x. So we assume that 1 plus cot x is equal to t. When we do derivative on both sides with respect to x, derivative of constant is 0, derivative of cot x is minus cosecant square x, and then derivative of t is dt by dx. That dx has been transferred to left hand side. Here we have plus cosecant square x dx, but here we got minus cosecant square x dx. So when we multiply both sides by minus sign, we get cosecant square x dx is equal to minus dt. So in the question, in place of cosecant square x dx we can substitute minus dt, and into 1 divided by 1 plus cot x. In this place we can substitute t, so we get this expression. We know that the integration of this value is this minus sign as it is log mod t. In place of t we can substitute 1 plus cot x, then plus c. I hope you understand this third problem. Now we will check this fourth problem. If you consider this fourth problem, integration of sin x divided by 3 plus 4 cos x whole square. By observation you can very clearly say that this is the composition function, this is the normal function. In the normally we take composition function as t and then we verify it. Here 3 plus 4 cos x is the first function in composition function. We will check whether when we do the derivative we can get sin x. Simply we can say that derivative of 3 is 0, 4, then derivative of 4 cos x is minus 4 sin x. Hence we are getting sin x when we do the derivative of this. Hence we can start this problem with the assumption that 3 plus cos x is equal to t, and then when doing derivative on both sides we get derivative of constant is 0, this plus sign as it is, 4, derivative of cos x is minus sin x, which is equal to dt by dx. Dx has been transferred this side. We need plus sin x dx, but here we have minus 4 sin x dx, so we can transfer this minus 4 to the opposite side. So we get sin x dx is equal to dt divided by minus 4. Now we can substitute these values in the question and we can integrate it. Integration of sin, in place of sin x dx we can substitute dt divided by minus 1 divided by 4, and then in this place 3 plus cos x we can substitute t square, this square as it is. So when we do we can rewrite this question as minus 1 by 4 into integration of t power minus 2 dt, and then when we do the integration for this we get t power minus 1 divided by minus 1. When we simplify it we get plus 1 by 4 divided by 1 by t. In place of t we can substitute 3 plus 4 cos x and then plus c. I hope you understand all these problems. In the next video we will continue to see some more problems. Thank you students. Thanks for your cooperation.